My world's so bright, it's hard to breathe, but that's alright. Hush.
Hey there, 6th grade. Today we're going to be covering lesson 2 of modular 13, or better known as chapter 13. Now, this lesson will cover area of triangles. We've been working on quadrilaterals, now we're heading towards triangles. So let me share my screen so you guys can take your notes. Remember, we're going to be doing this format for notes from now on. Let's see how it goes. If anything, we'll revert back to how we originally were giving out the notes. So again, if you're going to title this lesson, it will be called Area of Triangles. Okay, so the most important thing here is knowing what a triangle looks like. Well, you should be familiar with that. It has 3 sides and 3 angles. What do I mean about the sides? You have 1, 2, and 3. And the angles are, for some reason, this looks like an A. Let me fix that. You have 1 angle, you have 2 angles, and you have the 3rd angle here. All right, so again, the main point of this chapter is finding the area. You all should be familiar what area is. It's pretty much finding the measurements of the inside of the two-dimensional shape. In this case, we're talking about the triangles. Now, again, you're always asking me, how do they come up with these formulas? Let's go back into a story about rectangle. Yes, rectangle is usually the one that a lot of things originate from. So we have this rectangle, and let's just draw a line diagonally here, okay? And before we go a little further, let's talk about the rectangle. Normally, you have your length and your width. But a lot of times, just to make life easier, people call length base, right? And we're going to call base B as the variable B because base starts with the letter B. And for width, they usually refer that to as the height. So H for height. So you have base times height. And let's write this on the side because it's going to be very valuable pretty soon when it comes to the formula for a triangle. And you're asking yourself, well, we're talking about rectangle. What does this have to do with a triangle? Well, when we look at this rectangle and we made a dashed line at the center diagonally, we actually form 2 triangles, right? Triangle number 1 and triangle number 2. Now, what if we had no interest in the first triangle here on top and we were to cut it off? Let's say this was a sheet of paper. It was a rectangular sheet of paper and we decided just to cut this out and we just cared about the measurement of the second triangle here. Well, let's think about it. Now that you have a rectangle, which was area equals base times height, and you cut it in half, now you have half of a triangle, which is why you're going to write half over here. Because again, you have base times height from the regular rectangle, base times height, and now we are cutting it in half, leaving only one of the 2 triangles. In other ways, you can think about this as half of the triangle. Therefore, that's how this formula came about. If you're really confused with this, you can rewind it and kind of get the gist of it. And I do have other videos that kind of more or less relates to this topic. It goes a little bit more in detail. That being said, if you're still not convinced or you're still not sure by looking at this example of the rectangle, to be honest with you, it doesn't really matter. What matters is that you recognize this formula, right? I'm gonna write formula here, as finding the area of the triangle, okay? So whenever you see a triangle and they're asking for the formula, right? or to solve for area, you're going to use this formula. Now, that being said, they might give you the area, might give you the base, and then you have to figure out the height. Again, whenever they're talking about triangle and areas involved, this is the formula to use. Well, let's do some examples, and hopefully that clarifies or kind of solidifies your understanding of the topic. So I'm going to erase it. If you were not able to copy everything, don't worry. This is a video. You can rewind, pause it, copy everything down, and catch up. Okay? So we're going to have the first example. Example number 1. I'm going to draw out the triangle. Remember, there's different ways, different types of triangles. We're not going to be tested on knowing them. You don't know what you do not need to know what an isosceles is at the moment. Okay, so all you need to know is finding the area. So let's draw a line over here, and let's give numbers to these areas. So when we're talking about from here to here, that will be 15 inches. When we're talking about from here to here, that will be 25 inches. So now we have the numbers, right? Some of you are asking yourself, and I get this question all the time, Mr. Sakasa, where did you get these numbers? They're going to be provided to you. Whenever you have a problem, they're always going to give you the base, and they're always going to give you the height. Sometimes they might just give you the area. If they give you the area, they might be asking you to find either the height or the base. It all depends. They're always going to give you two numbers, or else you won't be able to figure out. It will be impossible to find out. So let's work this out. You have the formula. Again, I get it. You guys are doing online learning. Therefore, a lot of you guys could be cheating. Well, not technically cheating, but you have your little cheat sheet with all the formulas. If I were you, I'll try to memorize them, because next year you need to know them by memory. Okay, so you have area equals, remember, we're talking about the triangle, right? For some reason, it's not transferring my information. So you're gonna see me go back and fix certain letters, okay? So you have formula, right? For the area of a triangle is 1/2 times, remember that little symbol means multiplication, base times the height. Okay, so that's always going to be the formula used for triangles. Doesn't matter the type of triangle. Whenever you're placed with a problem that have three sides, right, and has three angles, you're talking about a triangle. Therefore, this is the formula that you will always be using. Even if they give you the area, you're looking for base, you still need this formula. So let's do the substitution. Okay, so put two dots. You have, let me write the substitution down here for more space. A equals, remember A is for area, right? You write the 1/2, and again, I already explained where you get the 1/2. It's part of the formula. You don't have to see the 1/2 in the figure. That 1/2 comes with the formula, right? Wherever you see this formula, that 1/2 has to be there. Because if it's not, well, you're doing parallelogram and rectangle, and that's not the case. We're doing triangles. Therefore, you gotta use this formula right over here. So you got 1/2 times the base. Well, the base will be the, usually it's found on the bottom part here of the shape. It's the linear part, right? And the base is 25 inches. So we're gonna write 25 inches times, now we gotta find the height. Height is from top to bottom. That is your height. So we're gonna write the height over here. So now all we need to do is solve. Okay, we'll put here A equals, well, you can go 1/2 times 25, and whatever you get from there, you multiply by 15, and your answer should be 187.5 inches square. Okay, so this is your answer. Some of you are probably asking, how was I able to do this? Well, you gotta do the calculations. I'm gonna do two ways. I'm gonna use the fraction form, which is 1/2, and I'm also gonna do the decimal form, which is 0.5. So 1/2 and 0.5 are the same thing. Some of you guys are asking, why not just use 0.5? Sometimes you do need to use the 1/2 to make life easier when you're dealing with fractions. So I'm going to do the decimal version for this example, and then for the other example, I'll do the fraction form. So you can have more or less an idea of how to do it both ways. It's the same thing, 1/2 and 0.5 are the same. So let's do the calculations. So this is how I was able to solve it. I'm going to write it down here. So the calculations are, I go from left to right. You can go 15 times 25, and then you multiply by 1/2. You can go whichever order you like. You can go 15 times 1/2. Generally speaking, you always want, if you see a whole number like 6 and 1/2, you know it's 3, right? And then you multiply the next one. It's up to you. I like going left to right. I'm gonna stay doing that for those that also do it that way. So you have 25, right? And you're like, where did you get that 25? Right over here. That is your base. And I'm gonna multiply that by the 1/2. And I'm gonna do it by decimals. So we're gonna see 0.5. You really don't need to have that 0. Just be known it's 0.5, right? 5 times 5 is 25. 5 times 2 is 10. Plus 2 is 12. There is no decimal placement here, but there's one decimal placement here. So you gotta go 1 to your left. That's 12.5. You're not done yet though. Let's write 12.5 over here. That is your 1/2 times 25 inches, which is over here, right? But we can't forget about this guy over here, 15 inches. That's part of the calculation. Remember, it's 1/2 times 25 times 15. So let's multiply 15 here. Remember, we're multiplying. 5 times 5 is 25. Carry the 2 on top. 5 times 2 is 10. Plus 2 is 12. Carry the 1. 5 times 1 is 5. Plus 1 is 6. So you drop down to 0. 1 times 5 is 5. 1 times 2 is 2. 1 times 1 is 1. So now you add them, right? Make sure they're all lined up so you won't get lost. And you get 1,875. If you put that as an answer, it's probably going to be marked half correct because you're not really finished. Because you got to look at the decimal placement. There's one decimal placement here. There's none here. So you're going to move 1 to the left. You do that, and there you go, 187.5. So you get the number part. Some of you guys are still getting lost with the units. Okay, this inch came from the problem. We're talking about inches, right? So you know it's going to be inches. This is another place where you guys are getting confused, is that it's the exponent part. You need to know the rules of exponent. Go back to your notes. We did notes. I showed you all the rules. Look back and kind of refresh yourself with exponents. I will cover it right now, but if you need more refresher, go back. It was covered. So let's work on the exponent. You remember how I went x? And this is not part of the problem per se. It just explains to you guys exponential rules. So when you're multiplying x times x, right? And I told you guys when you have a variable or a unit, right? In this case, it's a unit. You're going to always remember, they don't put nothing on top. You know there's a 1 there. Even though it's not there shown, there is a 1, right? Remember, we get lazy. We don't write all these things down when we don't need to. So there's a 1 and a 1. So when you're multiplying, if you have the same unit, same variable, you write it one time. Now what changes are your exponents. You have 1 and 1. And when you're multiplying, you add the exponent. So 1 plus 1 equals 2. So your exponent will be 2. In this case, we're working with inches. So you can remove the x and put inches. So it'll be inches times inches, right? 1 and 1 on top. You're going to go inches. You're going to keep the unit because you're talking about the same unit. 1 plus 1, and that will be inches squared. Okay? So this is the exponent part. This explains this exponent up there. This whole thing here that I worked on the left side, this whole thing here is the calculation portion where I got this number, 187.5. So that's example number 1. We use 0.5 rather than 1/2. They are the same thing, okay? If you don't believe me, well, make that into a fraction. Into a decimal. 2, denominator goes on the outside. Numerator is 1. 2 does not go into 1, so you have to put a decimal. You put a 0. Now, let me kind of fix that. 2 goes into 10 5 times. There you go, 0.5. Now let's do the next example, and this time we're going to be using the fraction. Remember what I said, the triangle, as long as it has 3 angles and 3 sides, it's a triangle. So let's do this triangle over here. And let me change the color here. So what we're talking about here to here, right? That is your base. It's a linear lines in the bottom. That's going to be your base, okay? So you have 40 meters. So I'm going to put in the numbers. When you talk about here to here, that will be 70 meters. And when you're talking about here from top and going straight down, right, all the way to the base, that will be it will be 50 meters, okay? So this is the problem they give you. You need to solve for area. And the first thing you have to do is write formula. Mr. Scassa, do I have to always write formula? You don't have to technically write the word formula, but you do need to write the following. A equals 1/2 times base times height, okay? And this is the formula you always use for triangle, as I mentioned before. Now we start to substitute. Okay, this is where you might get a little confused at first. Hopefully by the end you understand. You write area because that's what we're looking for. We're finding the area equals 1/2. The 1/2 is part of the formula. You always have to remember putting the 1/2. Else you're gonna get the wrong answer. Base. The base is from here to here, right? And that is 40 meters. Let's write 40 meters for your base. Now height. Remember, this is not your height. It's a slant. If it's slanted, that's not gonna give you the height. Just imagine if you went to the doctor's office and you're slouching, or you're kind of leaning against the wall in a weird angle. That's not gonna represent your height. If the doctor, let's say you're 5'8" and you're slouching or you're on the wall, the doctor might measure you, and you might measure 4 feet, and that's not an accurate measurement. You need to stand up straight, right? Linear against the wall. And that's what the height represents. And that will give you your height. Now, in this case, the person or the angle here is very long, right? It's leaning very far. That's why it has a bigger number than this guy over here. Now, but which one is standing straight? This one, right? It's from the top, the highest point of the shape, towards the bottom, the lowest point of the shape, right? So you have your height. Let's write that down, 50 meters. So now you're asking yourself, Mr. Casso, so what is this 70? Where do we put this in? Ignore it. They're just trying to confuse you. They want to know if you understand the concept of finding the height and the base, right? This has nothing to do with finding the measurement inside. You might need this for other types of calculations, but not to find the area, because the area is to find the inside um, um, measurement, how much it can actually hold up inside. So now that we have your substitution, all we need to do now is to solve, all right? So to solve, you go A equals 1/2 times 40 times 50. Well, in this case, you can kind of do it in your head, because half of 40 is 20, and 20 times 50 is 1,000. So let's write here, area equals 1,000 meters. Remember, yeah, meters times meters is meters square. and this is your answer. So some of you guys are like, Mr. Collins, I still don't get how you got the calculation. I get this part, but I don't get how you got 1,000. So let's work it out. And this time I told you I was going to use the 1/2 rather than the 0.5. But you can do it either way. It's up to you. I want you to see it differently. So let's go. 1/2 times 40. Mr. Castle, can I go 1/2 times 50? Yeah, you can. It's going to give you the same answer. You can play around with multiplying one to the other, and you're going to find out your response is always going to be the same. So 40, turn that into a fraction. You just put a 1. 40 over 1 is still 40. You're just making it look like a fraction. So remember, we got 1/2 times 40. That's what we're working on here. Can we cross reduce? Yeah. I mean, do you have to? Well, not necessarily, but it's gonna be a very long way. If whenever you can cross reduce, cross reduce. 2 can go into both of them, right? You gotta find the greatest common factor, and 2 is the greatest common factor in this case. So 2 goes into 2 one time, right? Let me change the color so it will be a little clearer. So you have 1 here, 2 goes into 2 one time, 2 goes into 40. Well, let's do here 40. 2 goes into 4 2 times. 2 goes into 0 0 times. So 2 goes into 40 20 times. So we're going to write 20 here. So now we got 1 times 20 on the top. Because remember, it's numerator times numerator, denominator times denominator. 1 times 1. You're going to get 20 over 1. And this is for 1/2 times 40. We cannot forget about this 50. You're still multiplying that by 50. So you have 20 over 1, which equals 20. Now let's do the next part, the next calculation part, which is 20, where you got 1/2 times 40 equals 20 meters. Can't forget about the unit. So you have 20 meters, okay? Let me write over here because we have more space. So you have 20 meters times 50 meters. So there's a little trick that you can do here. I'll kind of put it on the in this area. The first thing you should do is if you have a 0 and then you have units here that have numbers, you can multiply the unit. 5 times 4. I'm sorry, let me go back because we kind of solved it here. So let's look at here. 5 times 2 is 10, right? How did I get that 10? 5 times 2. Where did I get that 2? From the 20 meters that we just did the calculation. So we're going to multiply 20 times 50. Here's a short run that I was showing you. 5 times 2 is 10. How many zeros you have here? 2. So we add the 2 zeros here. And that's how you get the 1,000. But do you have to do it the short way? No, you can do the long way. 0 times 0 is 0. 0 times 5 is 0. Drop the 0. 2 times 0 is 0. 2 times 5 is 10. You add. There are no decimals, so you leave as 1,000. That's where you get the 1,000. All right, this is the long way. Let me circle it in black. This is the calculation way, which I suggest you always do. But if you want to take the short way, you can always go 5 times 2 is 10, right? And then you count the zeros. How many zeros are after the unit? 1, 2. 1, 2, right? So that's how you get the 1,000 by just looking at it. Some of you guys are like mental math. Yeah, this is mental math. But you never fail doing the calculation. So that's your example 2. And I'm going to leave it there. I will go over a couple more things in class. Probably give you a problem where you're not looking for area, but the area is provided for you. And this time you probably need to figure out how to find the base, something to note. If you're going to find something, you have to start thinking algebraic expression. That's pretty much what these things are at times. Any questions? If I were you, if you have any questions while you're working on the video, put it on the side of your notes. You write your question on the side where you're having some problems with. And when you're going over your notes before class, and I'm going over a problem, because I'm going to give you guys two more examples. And as we're going along and the question comes up in your head again while you're reading, remember, you gotta take out your notes while you're looking at your notes and the answer was not, it didn't click. That's where you start asking questions, and hopefully during next week's lessons, you guys can fully understand how to use these formulas. All it is memorizing formulas and integrating the numbers that they provide into the formula. Well, guys, it was a joy going over this with you guys. Hopefully, there's no glitchiness of the system. We can have a good.
My world's so bright, it's hard to breathe, but that's alright. Hush.